right. Today we're going to talk a little bit about rational functions. Um, so rational functions are just basically one polynomial divided by another polynomial. So g of x over h of x, where these are both polynomial functions. So a lot of the stuff that we learned about polynomial functions can kind of come in handy here, especially if we're dealing with complicated ones. But rational functions act a little bit differently. So let's take a look at the most basic rational function so that we can kind of get a handle on how these guys are going to work. So this is the reciprocal function, okay, 1 over x. So this is the most basic rational function that we're going to deal with. So whenever you're dealing with a new function, it's nice to basically just plug in some values and see what happens. So let's plug in 1. So 1 divided by 1 is 1. I'm going to jump all the way to 5. What's 1 over 5? Well, that's like 1/5. That's like 0.2. I'm going to jump all the way to 100. Okay, 100 is 0.0. 1 divided by 100 is 1/100th. Okay, 0.01. Now, what about on the negative side? Well, same kind of deal. We've got -1. 1 divided by -1 is -1. 1 divided by -5 is -1/5 or -0.2. If I do -100, we get -100th. So let's talk about what's happening here. So as x is getting bigger, y is getting smaller, but not smaller like where it's going down, 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 down. It's kind of leveling off. If I did 1 million here, then we would get 1/1,000,000th. Okay, so we get really, really, really close to what? Really close to 0. Okay, so as we go up and up and up, we're getting really, 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 really close to 0. And same thing if I did -1,000,000, sorry for my crowded spaces here, then we're going to get -1/1,000,000th. So we're going to approach, we're going to approach 0 from the other side. Okay. So the other weird thing about rational functions is what happens when we get really close to 0. So let's say I do 1/10. Well, what's 1/10 going to be? 1 divided by 1/10 is 10. Okay, remember when you divide by something that's less than 1, we actually get bigger. If I did 1/1000th, we would get, we would get 1,000. If I did 1/1,000,000th, if I got really, really, really close to 0, we're going to be really, really high. Like if I do 1/1,000,000th, okay, teeny, teeny, tiny, we're going to get 1,000,000. So the closer we get to 0, the higher we're going to get, unless we're on the negative end. So if I do -1 over 1,000, that's going to be -1,000. Okay, all of these numbers may be jumbling your brain a little bit. Let's look at a graph, because that's going to clear things up a little bit. So, see if I can find a better marker here. Ooh, that's a nice one. All right. So we've got 1, 1. We have 5/1/5. We have 100, 100/100th. Okay, so this is going to go, okay, and it's going to level out Because as x gets really, really, really big, we get closer and closer to our y being 0. Okay, well, what happens as our x gets close to 0? Well, remember 1/10 got us 10. Okay, 1/100th gets us 100. We're going to keep going up and up and up and getting closer and closer and closer to having x equals 0, but y is going to infinity. Okay, on the negative end, it's happening in a similar way. -1, -1, -5, -1/5, -10, -1/10. Again, we're approaching 0, but from the other side. Okay, so as x is getting more and more and more negative, we're getting closer and closer and closer to 0. Okay, now what happens here when we approach x equals 0 on the negative side? Well, we're getting closer and closer to, or we're going towards negative infinity as x gets closer to 0 on the negative side. So this is what our rational function looks like. Now, what you may notice is something that you may have learned about before, asymptotes. So there's a vertical asymptote right here. Okay. Now remember, vertical lines like this, the equation is going to be x equals some number. So this is all of the values where x equals 0. So why is there an asymptote here? Well, because there's a big hole because I can't divide by 0. Okay, that's not allowed. And whenever I get close to it on the positive side, I go to positive infinity. Whenever I get close on the negative side, I go to negative infinity. Okay, so anytime we have a rational function, you're going to be able to find its vertical asymptotes wherever your denominator equals 0. So vertical asymptotes are where your denominator equals 0. Okay. Now we're looking for our horizontal asymptotes. Well, you might see it right here. So we've got an asymptote right here where y equals 0. Well, why do we have that? So the horizontal asymptote is something a little different. Basically, it's the limit as x goes to infinity. In other words, what happens when x gets really, really, really big? Okay, does it go off into space, or does it settle down really close to a value? In the case of a lot of rational functions, they're going to settle down to a specific value. In this, you can tell, okay, as x gets really, really, really big, it's going to be 1 divided by a huge number, which is going to get us pretty close to 0. Okay, so we're going to deal with some more complicated ones, but if you understand this, if you understand vertical asymptotes are where our denominator equals 0, horizontal asymptotes are where x gets really, really big, then you're about halfway there to being able to deal with rational functions. Okay, we'll talk about some more complicated ones, but that's good for now.